Good day everyone. So today we're gonna solve a problem from the chapter 3 of thermodynamics. So let's begin. A 1 cubic meter tank contains 2.841 kilogram of steam at 0.6 megapascal. Determine the temperature of the steam using the van der Waals equation. So as you can see, I already written down the given, and the formula that we're gonna use would be a van der Waals equation, which is quantity pressure plus A over specific volume squared quantity specific volume minus B equals gas constant times temperature. So let's identify first the gas constant, the critical temperature, and the critical pressure. So the gas constant of the water is 0.4615 kilopascal cubic meter per kilogram Kelvin. The critical temperature of the water is 647.1 Kelvin, and the pressure is 22.06 megapascal, and converting it to kilopascal, this becomes 22,060 kilopascal. So, since we are looking for the temperature of the steam, therefore, the original formula will have a changes, and that will become T, or temperature, is equals to 1 over R, where R is our gas constant, quantity P plus A over V squared, quantity V minus B. And let's solve for the specific volume. You might be asking now that why should we need to solve for the specific volume when we already have a specific volume in our property table? The answer is, in the property table, it is at the critical temperature. But since we are looking for the specific volume only, therefore the formula that we're gonna use would be specific volume is equals to total volume over mass. So plugging in their value, the answer that the answer that we are looking for the specific volume is 0.3520 cubic meter per kilogram. So let's solve for the A. The formula for A is 27 r squared TCR squared over 64 PCR. So the R is the gas constant, the TCR is the critical temperature, and the PCR is the critical pressure. So plugging in their value, and as you can see, our gas constant is squared and also our critical temperature is squared. Therefore, we'll just gonna square them and also the units. So A is equals to 27 times 0.21298 kilopascal squared, m raised to 6 over kilogram squared Kelvin squared, multiplied to 418,738.41 Kelvin squared over 64 times to the for the critical pressure, which is 22,060 kilopascal. So canceling the common units, we got A is equals to 1.705 m raised to 6 kilopascal per kilogram squared. So let's solve for the B. So the formula to get the B is R TCR over 8 PCR, where R is the gas constant, TCR is the critical temperature, and the PCR is the critical pressure. So plugging in their value and canceling the common units, we got 0.00169 cubic meter per kilogram. So now we already got the value that we are looking for, which is the A and the B, and also we already got the value of the specific volume. Therefore, we're just gonna plug in their value in our formula or in our equation, which is T is equals to 1 over R, quantity P plus A over V squared, quantity V minus D. So by plugging in their value and canceling the common units, we got T is equals to 465.9 Kelvin. So this is the temperature of the steam using the van der Waals equation that we already got. So I hope that you learned something from me, and goodbye and thank you everyone.